Hey everybody. So we are getting into 5.3 part 1 today, points on lines and standard form. Okay, go ahead, take a minute, get that title. Don't forget the part 1, copy the example and that definition, and then we'll get into it. Okay, so points on line. This is fairly straightforward. We've been dealing with putting points on graphs for a few days now. It's saying that points on line. It says a point x comma y lies on a line if the ordered pair x comma y is a solution of the equation of the line. Okay, so basically that's going to be the question today. Is they're going to ask us, tell whether the point lies on the line. For us to say yes, when we plug in these numbers, it needs to be a solution to our equation, meaning it needs to work, it needs to actually equal, both sides need to be equal. Okay, so let's go ahead and take a try here on this first example. So, you guys know already from here, but remember, this is your x value, this is your y value. So when we go to plug these in, get your numbers in the right spots. So let's go ahead and do that. So I'm doing -2 times x, which on this problem is a 4, okay, plus y, which is 7. And the question is does that equal -3? So what I'm going to do is put a little question mark above that because that's really what we're wondering. All right, from here, some fairly simple math. It looks like we're getting a -8 plus 7. And again, we're wondering, does that equal -3? Well, you can see from here, we're getting a -1 on the left, okay? And that does not equal -3. Sometimes I like to just put a little cross through that, okay? So is this point a solution to the equation? Does it lie on the line of this equation? No, it does not. Okay, let's try letter B here. Same idea, same equation. I'm going to take -2, plug in my x value. This one there is 6, plus my y value 9. And then again, I'm wondering, is that equal to -3? All right, and you guys can see we're getting -12 plus 9. We might as well just do that in our head. -12 plus 9 is getting us -3. And on this problem, it does in fact work. I like to put a little check mark next to it. Okay, so does this point lie on the line of this equation? Yes, it does. All right, cool. So let's go ahead and try another problem a lot like it. Go ahead and copy this one and we'll give it a try. Okay, so pretty much the same thing it's asking. Tell whether the ordered pair is a solution, or in other words, does this point lie on the line of this equation? So let's plug it in and find out. So I'm doing -8 times x, which is -5, plus 5 times y, which is -7. And we're wondering, does that equal -5? All right, so from here, looks like we're getting what, 40 plus -35. Does that equal -5? All right, well, be careful here. It might be tempting to say yes, but remember, when we have a plus and minus side by side, really that minus supersedes the plus sign. This is 40 minus 35. All right, and we know 40 minus 35 is just 5. All right, so on this one, again, we're wondering, does that equal? Sometimes I forget those, but no, 5 does not equal -5. So is this a solution to this equation? No. Alrighty, so from here, I'm going to have you guys go ahead and try this one out on your own and see what happens. All right, so plugging in my x value, -2, plus 2 times my y value, +3. And we're wondering, does that equal 4? All right, well, it looks like 2 times 3, we're getting 6. So we're getting -2 plus 6. We're wondering, does that equal 4? Again, be careful on this. This is really, if we read this backwards, just 6 minus 2. And we know 6 minus 2 is 4. Okay, so we are getting something that works. 4 does equal 4. This works out. So does this point lie on the line of this equation? Yes, it does. Okay, and just so we're sure, and we're going to get into this eventually, if I were to graph this equation, just say, for example, I were to graph this equation and say it was this line, let's see, -2, 3 would be, so say we got this line when we graphed it. The point -2, 3 would land right here on top of our line. That's basically what it's saying. This is just, I don't know if this is actually the line that this equation makes, but that's the idea here. Okay, so next type of example says put the equation in slope-intercept form. Okay, or in other words, solve the equation for y. Go ahead and copy this and we'll do that. Okay, so getting equations into slope-intercept form, we've actually done this in a previous lesson. We just didn't call it slope-intercept form, but we had problems where we were solving for different variables. If you guys remember, it was, I don't know, maybe 3 or 4 weeks back. So yeah, slope-intercept form is just when we solve for y, get everything that isn't y to the other side of the equation. And if you guys can notice, the thing we need to get rid of is this minus 2x. All right, and we want to get rid of the whole minus 2x, all at the same time. It's being subtracted, or, it's a minus 2x, so we're going to add 2x over to the right side. Okay, that makes it, gets rid of it. This is a positive y, which we can just write as y. Over here, just a couple things. These are not like terms. I cannot add these. This isn't going to give me like a 4x, right? So I'm going to write them side by side. And what I want you guys to get used to is writing the term with the variable first and then the constant. So I'm actually going to put this positive 2x first and then the positive 2. Okay, because this is slope-intercept form, which, by the way, we should write this out. I guess the generic form of slope-intercept form is y equals mx plus b. Okay, and I'm making those colors different because you guys will, I'm sure you've seen this before, but you'll notice that the numbers that are in the M spot, which would be this 2, and the number in the B spot, which would be this 2, they represent things, and we'll eventually use them to graph these equations really quickly and easily. But yeah, go ahead and get this on your paper just to show yourself, yeah, that's slope-intercept form right there. Okay, let's try another one here. Same directions, you don't need to get those again. Go ahead and copy this equation real quick. Okay, so we're getting this one in a slope-intercept form. We want to solve for y. Couple things. We have this 4x being added, and we have this 3 being multiplied. And just like any other problems, whenever we go to solve, we're going to deal with addition or subtraction first. Okay, so the first thing is getting rid of this 4x by subtracting the 4x over to the right. Okay, so they're gone. We have this 3y on the left. On the right, I'm going to start getting this into slope-intercept form. So I'm going to first put the minus 4x and then this positive 12. Okay, now we can get rid of the 3 that's being multiplied by dividing into both sides. Here's a big thing. It divides into all of the other side of the equation, not just that minus 4x, but this whole thing. Okay, so let's see what happens here. These are gone, and I'm getting y equals negative 4x divided by 3 and 12 divided by 3. This is dividing into both of them. Okay, well, first thing, 3 doesn't divide into negative 4 evenly, so we're going to leave that as a fraction, and I'm going to write it like this, negative 4 over 3, and then this x is actually just going to go next to my fraction. Okay, that's the best way of writing it. Over here, 3 does divide into 12, so we can actually do that division, and that gives us a positive 4. Okay, just be really careful, guys. It's really simple, or I guess easy to forget to divide this number into the second term and just say, oh, okay, I'm bringing down the 12. I got a 12 here. No, be careful. It divides into all of these terms. Okay, so there's our slope-intercept form, which, by the way, this is our m value, and this would be our b value. That'll mean more when we get into the next lesson. Okay, and I'll let you know what m and b means. I'm just trying to get your brain to start thinking of it that way. Okay, so I'm gonna have you guys try one on your own. Go ahead and copy, you don't need the directions. Go ahead and copy this problem and get it into slope-intercept form. Try it out. Okay, so first thing, 2 is being multiplied. We'll eventually get rid of it. But this minus 6x, we need to get over to the right. So we're gonna do the opposite. We're gonna add that 6x over to the right. So they're gone. We have the 2y equals positive 6x. I'm putting that first, and then this positive 10. Okay, now I can divide this 2 from both sides. Okay, and we're getting y equals, this time 2 does divide into this term evenly, so I'm going to do that. 2 goes into 6 3 times, so I'm going to write it as a 3 and then the x next to it. Don't forget to divide the 2 into the 10 as well and get a positive 5. Okay, and there is my slope-intercept form. All right, so yeah, it was a quick one today, guys. But yeah, the next lesson we'll get into actually graphing in slope-intercept form. You'll see it's really simple stuff. Okay, I'll see you guys.